Okay, students, so in this one right here, we're going to find the sector area. So central angle over 360, and it says approximate. All right, sector area over pi r squared. Central angle is 15 over 360. Sector area, pi 5 squared. All right, so one way to do it, if it's approximate, let's just talk about how to be careful and how to do things when we're solving for approximate area. So, some simplification took place. Now I'm going to cross multiply, but let's keep all our work incredibly organized. All right, I'm going to have 15 times 25 pi over 360. Instead of writing SA, I'm going to write x. All right, and then actually let me rewrite it as 360x. I'm going to go ahead and do 25 times 15, which is 375 pi. All right, so again, when it's approximate, I can just keep my work really organized. 375 times pi divided by 360. Again, I plug this all into a calculator very carefully, and I can get an approximate answer of 3.3. All right, again, just be careful. Cool beans, cruising right along. Carlos has he has 400 feet of fencing to completely enclose an area on his farm for an animal pen. All right, you can make the area a square or a circle. So let's go ahead and just draw a square and a circle really fast. All right. If he uses the entire 400-foot fencing, which figure would yield the greatest area and by approximately how many square feet? All right. So this is a square. This is some side length. 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 All right. Remember, perimeter of a square is 4 times a side length. All right. In this case right here, it said we have 400 feet of fencing. So 400 feet equals 4s. Divide both sides by 4, and 100 equals a side length. All right, so each side of this fence is 100. Then the area of a square is just side length squared. So it's going to be 100 squared, which is 10,000. So if he has 400 feet of fencing, he can make a square with an area of 10,000 square feet. All right, now let's focus on this circle. Well, we can say, well, the circumference of this circle is 2 pi r. All right, well, we're gonna have to get approximately here, but we can figure out the radius of this circle. And again, be careful when you plug this into a calculator. We have to use parentheses. It should look like this, so it knows you're dividing 400 by 2 and the pi. It's about 63.66. All right, well then we can use the area of a circle, which is pi r squared. So the area is going to be pi 336.66 squared, which equals, oops, hold on, this said 63. I had a brain fart and wrote it backwards. That should be 63. All right, square it times by pi, and woo, we get a bigger number. Who would have thought that? A little fun fact, circles actually maximize area when you only have a certain amount of things. All right. So that means that the circle has larger area, all right, and you can calculate it by doing the area of the circle minus the area of the square. So 12,732.4 minus 10,000, so by about 2,732.4 feet. Cool beans. All right, and then what do we got? 2 more problems. Just again emphasizing some of the bread and butter we've been talking about these last few days. Again, we got sector area. Area of a sector of a circle is 54 pi. The arc length is 6 pi. Find the radius. So again, this is one of the ones where we're going to do arc length over 2 pi r. Sector area over pi r squared. Again, realize which one goes with it, which arc length goes with the circumference, sector area goes with the area. All right. Arc length is 6 pi, it told me. 2 pi r. Ooh, a lot of simplification that's going to go on. Sector area is 54 pi. Pi r squared. So, first off, the pi's cancel. Bada, 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 bang. 6 over 2 becomes 3. Leave the r. 54 over r squared. Then it's just cross multiplying. 3r squared. 54r. Take it step by step. 54 divided by 3 is 18. Oops. R squared equals 18r. Divide both sides by r, and we get r equals 18.